But see, this aircraft right here has a function that allows the auto thrust to maintain a safe margin in case of gusty wind conditions. We call that ground speed mini. So the V approach value right here is not a static value in our aircraft. It means once you've calculated, or the aircraft has calculated V approach, and it is a target speed on your PFD, that target speed can move up and down as a function of gusty conditions outside. This is a function that is available for the Airbus family aircrafts through the auto thrust. We call it ground speed min. The ground speed mini function shows an indicated V approach target, a dynamic approach V approach target moving up and down if we have gusty conditions. This is from the FCOM, so I want to read this out to you, as this is how the Airbus philosophies dictate what ground speed mini function is. The objective with the ground speed mini function is to take advantage of the aircraft's inertia when wind varies during approach. This objective is achieved by providing an adequate indicated speed target, moving up and down, in managed speed, and this is represented by a managed target. When the aircraft flies this indicated speed target, the energy of the aircraft is always maintained above the minimum level, ensuring aerodynamic margin versus a stall. During the approach, the flight guidance of the aircraft continuously computes the managed target speed in order to take into consideration gusts and wind changes. It's using the ADIRS, the inertial reference of the aircraft, to physically be able to establish what are the winds around the aircraft at any given time doing. Because during an approach, when we come into land, from let's say 3,000 feet and down to touchdown, while we have the reported tower winds at the runway axis on the ground, these winds may be very different in the 3,000 feet coming into land. If we had to account for that manually, as I will also illustrate here, we would have to vary thrust greatly, but it can put the aircraft into a dangerous scenario where the aircraft may not have enough inertia in case of very gusty conditions. The ground speed mini function uses auto thrust and the ADIRS for its establishment of the actual winds around the aircraft. The auto thrust must be on, and on the FMA in the first column, we must have speed indicated. So the auto thrust is in speed mode. Auto thrust in speed mode means that the auto thrust is using thrust variations to target the speed for the aircraft. So if the speed goes up, the thrust goes up, and vice versa. And the aircraft therefore pitches for its attitude, hence the glide slope if it's an ILS. Let's take a scenario here, and I'll walk you through how the ground speed mini function works. Let's take a scenario here where the aircraft is coming into land, let's call it 2,000 feet down to the ground. We have the winds reported at the ground and at the runway axis. That doesn't change. But as you're going to see, we're going to be coming down with first a 20 knot headwind straight on the nose of the aircraft. That is equal to the reported winds at the ground for my scenario. But then as we come down, we're going to have a lot of gusty conditions. So my 20 knot headwind is going to change to a 50 knot headwind and then disappear to become a 10 knot headwind, all in the span of about 1,500 feet during an approach. This can be devastating to an aircraft, especially one that has jet engines that take time to spool up. Let's look at how the managed speed, the ground speed mini function, operates and accounts for this versus an aircraft with selected speed, which means ground speed mini function off or not available. Let's start the scenario here with us coming into land and experiencing actual winds 20 knot headwind equal to the reported winds on the ground, which is also 20 knots. So there are no gusty conditions right at this moment. You will see here that the MCDU approach page here has been set up with the reported tower winds 270 at 20 knots. This is the winds reported at the ground. We set them up during the approach setup. And the flight management and guidance computer will use that to calculate the V approach. The speed target is now obtained. V approach is the magenta triangle right here. This is from managed speed as the ground speed mini function is working. And the thrust on the engines is stable to maintain that speed. Let's look at how the individual speeds are now calculated. Starting with the V approach. The flight management and guidance system calculated in my scenario here V approach as VLS plus the highest of 5 or 1/3 of the tower headwind. The tower headwind that I put in was 20 knots headwind. So 1/3 of that is higher than 5. So my V approach is 134. That is VLS for config full. You can also see that up here. Plus 6 knots, which is 1/3 of 20. The system will always round up or down to the highest value. It gives me a V approach at 140. That is the target speed here, the magenta target, that the flight management and guidance computer has set. It's also what the auto thrust is now maintaining. The ground speed mini is the minimum ground speed that the aircraft has to maintain in order for it to have a significant or an established margin to the onset of a stall. The formula used by the flight management and guidance computer and the auto thrust to establish ground speed mini is based on, again, the tower wind you put in. It is using V approach, which is calculated here, 140, minus the tower headwind. Hence, the ground speed minimum in my approach scenario will be 140 minus 20, that is 120 knots. The ground speed mini function will not allow the aircraft's ground speed to go below 120 knots. In order for it to maintain 120 knots, it needs to fly an indicated speed of 140. Hence why the approach speed is 140 and the minimum being 120. We call it the approach target speed, the indicated target. It is magenta when we have managed function, and the formula used for the target right here is V approach plus any gust. In the scenario I have in front of you right now with the 20 knots headwind, there are no gusts. So you can then take 140 plus the 20 knots we reported on the ground and the 20 knots which the ADIRS is actually experiencing at a given time, and it gives you a target of 140. That is the target you see right there. This is what the aircraft is flying. If the target changes up or down, then the auto thrust will use thrust to chase that target, and that's what we're going to be seeing coming up. And just for the overall understanding here, the actual ground speed for the aircraft is, in this case, 120 knots. We can find the actual ground speed of the aircraft any given time by taking the indicated speed minus the actual headwind. The actual headwind I said was 20 knots. Subtract that from 140. The aircraft is right now flying a ground speed of 120 by maintaining 140 on the indicated speed. As long as the aircraft is flying that indicated speed, its ground speed is 120 knots, and that was the minimum calculated by the system as ground speed mini. If, on the other hand, I had the ground speed mini function disabled, auto thrust off, or I'm flying a conventional aircraft, well then the V approach calculation right here, that just becomes the target speed. That target will not change. it will be 140 with a blue triangle selected. That will show regardless of whether or not there are changes outside in the wind conditions, such as gusts. Let's go down a little bit further. Now the aircraft is experiencing a significant increase in headwind, a gust. My headwind, the actual wind at the aircraft's nose, is going to increase from 20 knots to 50 knots. Remember, it's just a gust, which means it's very short-lived. But let's see how the aircraft react to it, both with and without ground speed mini function. First of all, the aircraft, when you get a gust like that, is going to create a significant increase in lift on the airfoils. So there's going to be an increase both in the aircraft's attitude, the aircraft might balloon up, and there's going to be an increase in the speed initially as the forward gust also affects the pitot tubes, etc. There are no changes to the MCDU values because the tower wind didn't change, and the only thing that can change the values in here are the tower winds. Now it just becomes about what the ground speed mini function does and how it's using engine thrust to ensure that this aircraft does not get dangerously low on energy. So what happens with the auto thrust on and the ground speed mini function working? Well, the reapproach is the same, it's still 140. Ground speed mini was 120 knots, the minimum ground speed that the aircraft should fly at any given time. But the target speed here changed. The target speed, and you can see it right here, the magenta target moved all the way up to 170 knots. It's because it's using the V approach 140 plus the gust. And right now the aircraft is experiencing a gust established by the ADIRS of 50 knots. And it's able to tell the system that this is a gust, go ahead and increase the target. Why increase the target? Well, if it increases the target, then the engines would have to spool up to be able to go up and get that speed, and that is the function. In my case right here, the indicated target speed goes all the way up to 170 knots, and the engines will gently spool up to target that speed. The aircraft will fly for faster speed. The ground speed in this case is the indicated speed, 170, minus the actual headwind, which is 50, so it's maintained at 120. By increasing the target to 170, the aircraft ensured that the ground speed was maintained at or above the minimum ground speed, which is 120. Let's look at what happens if we have selected speed, so ground speed mini function is not available. In this case, the target speed will still be 140. It can't change because it's not dynamic anymore with the ground speed mini function off. You will get an initial increase because of the gust in lift as well as the forward speed, as you can see right here. So how are the pilots or the engines, in case of this scenario, supposed to recover from that or respond? By decreasing the thrust. It will decrease the thrust all the way down to idle to go down and get that speed to compensate for the increase in forward headwind. But because it's just a gust, it's gonna go away, and then we have a problem. So if I didn't have the auto thrust function, my engines would spool down to compensate for this increase in gust to maintain 140. And it isn't so much about what it does right here. It's the fact that this is a gust. What happens now once the engines are down in idle and that gust disappear? The ground speed in this particular scenario is 90 knots. The values seem very low to you, but at this particular instant, because of the increase in forward wind, we have enough aerodynamic lift to support flight. But what do we do when the Gust goes away, that aerodynamic lift decreases with the engines in idle. And that brings us to the last part, which is when the aircraft goes out of that gust further down, and in my scenario here, that headwind changes from a 50 knot headwind to a 10 knot headwind. With the ground speed mini function working, remember, it targeted, because of the gust, a much higher speed, with the engine slightly spooling up. And as you can see right here, my speed was 170. Now it's nicely decreasing back down to 140. And what did the engines do? The engines had higher power setting, so they're just spooling down slightly, not so idle. The calculations by the FMTC, the approach is the same 140. Ground speed mini is still 120 knots. The target speed is V approach plus any gust. Now there's no gust, the gust went away. So 140 plus 10 knots, which is the actual headwind, minus the 20, which is reported. And that gives us 140. Another way of saying it is there are no gusts. So V approach is the indicated target speed. Because the aircraft used engine thrust and the ground speed mini function to go up and get a higher speed before, now that the gust went away, it has energy, forward energy and inertia to then trade off and allow the speed to come back down, not allowing the ground speed to go below its minimum value. But if this had been the scenario without the ground speed mini with a selected target, the target wouldn't be 140, but remember, the engines had spooled down to idle. And now when the gust went away, all that aerodynamic lift disappears in an instant, and the aircraft starts to sink. The aircraft now has to generate forward thrust to compensate, and that is the problem, because jet engines take time to spool up. It can take as much as 8 seconds for an engine to spool up from idle power to sustainable thrust to obtain in this scenario. And during that time, the aircraft is sinking, it's not generating enough lift. How would the pilots compensate? If the aircraft starts to sink, you're going to start raising the nose. This brings the aircraft dangerously low on speed into a stall scenario. The ground speed mini function ensures that the aircraft always have the minimum inertia needed in gusty wind conditions. So when you get a gust, the engines will spool up. How does the engine spool up? By calculating a target and putting a higher speed target so the engines will spool up to get it. That means when the gust then goes away, that target can come back down. The indicated target in a managed scenario with ground speed mini function working is how the aircraft does this. But take the ground speed mini off, turn the auto thrust off, and you will not have this function, and gusty wind conditions are not accounted for by the system. This is why we always fly with the auto thrust on, and why even doing manual raw data approaches and manual flying, we still fly with the auto thrust on. It's also why during the approach checklist, we verified the first column on the FMA, auto thrust, speed.